Day 2 on section 9.5, or day 2 on the quadratic formula. Today you're going to be given a variety of quadratic functions and asked to solve the problem using any method you want. So here's a list of the tools we have in our tool bag. This has taken us about 3 chapters to get all these tools in our tool bag, but these are our choices to choose from when solving a quadratic function. So the factoring tools we learned in chapter 7, these are kind of the steps we go through to see if a problem is factorable. Is the problem already factored? Does it already look like a multiplication problem? Can you pull out a greatest common factor? Does your problem happen to be the difference of 2 perfect squares? For example, x squared minus 4. X is a perfect square, x times x. 4 is a perfect square, 2 times 2. So you could factor this into x minus 2, x plus 2. Can use grouping. That will only work on a polynomial that has 4 pieces, or a quadnomial, I call it. And then lastly, the AC method. If all of those fail you, there are some other choices here. Square roots. That works well if there's only one unknown variable in the problem. Completing the square, we went over previously, most previously, which works for a lot of problems, but is most efficient when your b variable is even and your a equals 1. And then your last tool in your tool bag is the quadratic formula, which does work for any problem, but isn't always the quickest method. So our goal today is to choose the method that we think is going to work fastest. Okay, here's our first example. So, when I look at this problem and go through kind of my checklist of options, is this problem already factored? Does it look like a multiplication problem? No. Can I pull a greatest common factor out of all 3 terms? No. Is this a difference of 2 perfect squares? No, this is a trinomial. It is not a binomial. Can I use grouping? No, again, this is a trinomial, not a quadnomial or a 4-piece problem. Can I use the AC method? Remember, the AC method is when you multiply the a and c variables together. My a is a 1 in this case. Looking for things that multiply to 12, 1 times 12, but will add to 8. I know that 6 times 2 multiplies to 12, and 6 plus 2 adds to 8. So on our checklist of options, I could stop right here. The AC method is going to work in this case. This problem would factor into x plus 6 times x plus 2. Then my final answers would be the 2 values that make this piece equal 0. Negative 6 plus 6 would make 0, so one of my answers is negative 6. Negative 2 plus 2 would also make 0, so my second answer is negative 2. Okay, so we use the AC method on that particular problem. Here's the next example. Okay, this problem needs some rearranging to be done before I start going through my tools or my list of options. I see some like terms here. These are both z squared terms, so I'm going to subtract 2z squared and move it over to the left side of my equation. Okay, 6z minus 2z squared is 4z squared. I'm also going to move the 7z and the 5 over to the left side of the equation, so that would be a negative 7z and a negative 5. Now we have our equation equal to 0, and I can go through my list of options. Okay, option number 1, is it already factored? No, does not already look like a multiplication problem. Can I pull a greatest common factor out of all three? Not in this case. Is this the difference of two perfect squares? No. Can I use grouping? No. AC method. Let's try that. Multiply the A and the C. Looking for things that multiply to 4 times 5 is negative 20. So multiply to negative 20, but add to the middle term negative 7. So some things that I know that multiply to negative 20 are a negative 2 times 10, or a negative 10 times 2, or a negative 4 times 5, or a negative 5 times 4, a negative 1 times 20, a negative 20 times 1. Okay, all of these options, however, do not add to negative 7, so the AC method is not working here, but there's still some more options. The next option is using square roots. Remember, that tool will only work if you have one unknown variable. In this problem, I have a z squared and a z. Those are two different unknowns, so that tool will not work. Completing the square. It's most efficient when your b variable is even. In this case, my b variable is a negative 7. That's odd. And when a equals 1, my a in this case is a 4, not 1. So I could use completing the square, but it's definitely not the most efficient choice. I'm going to have to go to the last tool in my tool bag, the quadratic formula. Okay. Quadratic formula, it starts off with negative b, which in this case is a negative 7. So I have a negative 7, the negative from the problem and the negative from the formula, plus or minus the square root of b squared, negative 7 squared, minus 4ac. So minus 4 times my a, which is 4, times my c, which is a negative 5. Okay, that's just following that formula we learned yesterday, over 2a. So over 2 times the a variable, which is a 4. Okay, let's just write this a little bit simpler. I know a double negative is really just a positive, so this would just be a 7 plus or minus the square root. A negative 7 squared, negative 7 times negative 7 is 49. A negative 4 times 4 is negative 16. A negative 16 times a negative 5 would be a positive 80. All over 2 times 4 is 8. Okay? So by solving this, this will give us our two solutions. You can feel free to plug this into your calculator. You would first plug in 7 plus the square root of 49 plus 80 divided by 8. And then the second time around, 7 minus the square root of 49 plus 80 divided by 8. Again, if you're plugging this into just an iPhone at home, it might be helpful to solve the numerator first, press enter, and then divide by 8. Break the problem into steps. Okay, if you plug this into your calculator correctly and round your answers, you should get 2.29 for one of the solutions and a negative 0.54. Okay. So for this particular problem, factoring didn't work, square roots didn't work, completing the square would not have been efficient, so we did need to turn to the last tool in our tool bag. In closing, we're going to look at this example. 9x squared minus 5 equals 4. Now, rather than going through every tool, I'm just going to jump right down to square roots. Use if only one unknown variable is in the problem. I can clearly see there's just an x squared in the problem, just one unknown. So I can solve this problem using square roots. My goal is to get x by itself. first. I'm going to add 5 to both sides. I have 9 equals 9x squared. Then divide by 9, both sides. I have x squared equals 1. And lastly, take the square root to get x all by itself. Remember, when you take the square root, you always have the plus or minus answer version. The square root of 1 equals plus or minus 1. Okay, so this particular problem, I recognized right away, hey, there's just one unknown in my problem, unlike the previous examples I've done where there's both a z squared and a z in the problem. That's 2 unknowns. This just had an x squared in it. Okay, so today you'll be kind of searching for which tool you think is fastest, use the tool, and solve the problem.